Today, we're diving deep inside the heart of a massive engine. We're going to look at a measurement so small, but so incredibly critical, that getting it wrong can cost a fortune in fuel and repairs. This isn't just your standard maintenance check, folks. This is about the secret to an engine's raw power and efficiency. We are breaking down exactly how to check a fuel pump cam lead.
So, what's the big secret? How does a colossal engine like this maintain perfect timing and hit peak performance every single time? You might think it's all about some complex computer, but often it comes down to a tiny physical measurement. We're talking just a few millimeters. That makes all the difference in the world.
All right, let's start with the basics, the what and why. Before we can measure anything, we got to understand what fuel cam lead actually is, and more importantly, why it's so vital for the engine's health.
Okay, so straight from the official service manual, the fuel cam lead is the number of millimeters the plunger is lifted from its bottom position when the main piston is in top dead center, or TDC. Let's break that down. In simple terms, it's a very specific height measurement, taken at a very specific moment, right before the fuel gets blasted into the cylinder. And this diagram right here just lays it all out perfectly. See that egg-shaped piece? That's the fuel cam. As it spins, it pushes that pump plunger up and down. Now that movement has to be timed perfectly with the main piston hitting its absolute highest point. That's top dead center. The lead is just how far up that plunger has already been pushed at the exact instant the piston hits the top. It's like giving the fuel injection a critical head start.
All right, now for the how-to. Part 1 is all about preparation, and believe me, just like any precision job, the prep work is everything. You absolutely cannot get an accurate reading without setting the stage perfectly. There are 3 really key steps to get ready. First, you dismantle the puncture valve, that's a safety device, so you can get access. Second, and this one's a biggie, you have to make sure the reversing mechanism is set to ahead. This ensures your timing for forward motion. And finally, you carefully insert the special measuring pin until it's resting right on top of the pump plunger. And this image shows that final prep step perfectly. You can see the measuring tool is in place, it's seated correctly, and it's ready to give us our readings. Getting this set up just right is absolutely essential for what's coming next.
With all the prep work out of the way, it's time for part 2 of our how-to, capturing the measurements. We need to get 2 very specific readings, which the manual calls X1 and X2. So our first mission is to find the absolute lowest point of the cam's rotation. Think of this measurement as our baseline, our 0 point for the whole procedure. So the technician will slowly turn the engine over, watching that measuring pin until it drops to its lowest possible point. The very instant it hits the bottom, they'll use a caliper to measure the distance from the top of the pin to a fixed reference point. That value becomes our baseline, and we call it X2. Okay, we've got our baseline X2 recorded. Now we move on to the second critical position. The engine gets turned ahead until the main piston for this specific cylinder hits top dead center, the very peak of its travel. So now the piston is at TDC, the cam has rotated, and it's lifted the plunger. The technician measures that exact same distance again with the caliper. Of course, the value is going to be different this time. And this new measurement is what we record as X1. And this, my friends, brings us to the aha moment, calculating the lead. We've got our 2 numbers, X1 and X2, and now it's time to put them together and see what they tell us. Now, after all that careful preparation and precise measurement, you might be expecting some kind of complex formula, right? But the beautiful thing about this procedure is that the formula is incredibly simple. And there it is. C, which is our cam lead, equals X1 minus X2. It's just the difference between the measurement we took at the lowest point and the measurement we took at top dead center. Simple subtraction. That's all it takes to find the exact lift. That final number C, that's our answer. That is the fuel cam lead measured in millimeters. It's a tiny number that tells us absolutely everything we need to know about this engine's injection timing. So we have our number, but so what? What do we actually do with it? Well, this brings us to the final and maybe most important section, the so what. This is where we turn a simple measurement into meaningful action. So, what happens now? Well, the technician records that result and compares it against the original factory data from the testbed. If it's out of spec, even by a fraction of a millimeter, it means fuel is being injected too early or too late. That leads to bad combustion, wasted fuel, and potentially serious long-term engine damage.
This number is also kept on file to track engine wear over time. If an adjustment is needed, they follow a specific procedure to fix it. And then the very last step is to simply remount that puncture valve.
This one single measurement really shows you just how deep the rabbit hole of engine maintenance goes. A few precise millimeters, and it's just one of dozens of critical checks. It really makes you wonder, right? What other tiny, precise alignments are working together in perfect harmony to keep these incredible machines running at their absolute peak?